Hey, cool. Well, we are at 8:45, so I think we should get this call rolling here. Good morning, everybody, first off, and welcome to our first virtual Corteva Seed Grower Combine Clinic. I think I know most of you guys on the call, but my name is Stacy Rampton, for those of you who don't know me. I am the soybean production agronomist for Manitoba and have the pleasure of being your moderator this morning. We've got some folks calling in, I believe, from Wahpeton, North Dakota, Manitoba, and then also Southern Ontario. So we've got a pretty eclectic group that's about to get started into harvest here in the next couple of weeks. So thought it was pretty pertinent to get in and try and have a informal harvest clinic as close to harvest as we could without impacting you folks in the field. Although I think I know a couple guys on the call that are in their swathers calling in. So thank you for taking the time to call into this. So I can only speak for Manitoba here, but I think in general, a late start to planting was something that many of the folks on the call dealt with this spring. And knowing this, we just wanted to get ahead of a likely delayed harvest. Now, typically in Manitoba, a delayed harvest for us would mean that we are generally going to be combining higher moisture grain in low or declining temperatures under wetter cutting conditions. So the experts on the call this morning are going to lead us through a few ways to fine-tune combine settings, specifically for seed soybeans, and how to adapt to some changing conditions throughout the day while achieving top quality seed production from both a appearance and integrity standpoint. There are a lot of quality factors we can control at harvest and even improve once that product hits the bin. So I think it's just kind of important if we can prepare for all the potential fall challenges we're going to have this year and just overall improve our seed quality is the goal. So this morning, to start us off, I'd like to introduce you to the combine expert himself, Scott Chapman. Scott has been with Ag West in Morden for over 26 years. And with that comes a wealth of knowledge and experience for us to glean from. He is a Red Seal tech with a large background in technology, and he lives in Morden, southern Manitoba, for those of you who don't know, and is very familiar with combining crops that require added care, such as soybeans and edible beans. So this is an opportunity for us to pick Scott's brain on how we can best achieve the greatest quality using Lexion specific combines. And we want this to be as interactive as possible, so feel free to ask questions to him directly. Text me if you need to. There's also a chat box in the bottom here. I think we want this to just be as informal as possible and gain as much info as we can from Scott as we can. So good morning, Scott.
Good morning. Thanks for having me.
Yeah, thank you for joining our call. I think for us to kind of kick things off, I think I'm giving you a bit of background here on most of the growers on the call. But just to recap, most of the growers on the call are running Lexion combine models, 480s, 570s, 580s, 740s, 760s, and 8700 classes. So I think just maybe to start us off, like we're getting into a scenario where we're going into a potentially late season with higher moisture beans. From your perspective, what are some recommendations we should be keeping in mind on these combine models specifically to have a good quality bean?
Yeah, so we're gonna be working with two completely different animals with the 8,000 series versus, or 7,000 series versus everything else. So I'll start with the 700 series first. There's going to be some crossover, of course, between the two generations of combines, but definitely some improvements in the 8,000 series. So the number one thing, guys, when we're dealing with our bean situation is our APS area, making sure that we are having the correct APS grates. I recommend the round bar grates for any of the series of combines, especially when we're dealing with beans. The disawning area or the area just below that, we're going to be able to have the ability to open and close that, of course. And based on the amount of pods we're getting, those can be open and closed. The second area that of concern is definitely the threshing area. And we want to make sure that we have our intensive thrashing segments out. That's a big one that guys overlook and sometimes forget that they put in towards the end of the season. And if we have our intensive thrashing segments in any of our models, that's going to create a huge pinch point. And definitely bean quality is going to deteriorate from that point on. In the 8000 series, we also have the ability to change the bottom tray in our concave, which is huge. We were never able to do that in the past. So the 7 and 8000 series guys that are out there, if you are going to be growing any level of beans volume wise, we are definitely encouraging to change the bottom tray in the concave. A little bit easier done on the track machines than it is the duals machines, but nonetheless, we have learned that it's hugely valuable to do so, to get started off anyway. And then after that, we get into our impeller areas, which is another hugely important part when we're running with low speeds. Generally, we want to have as much crop on crop as we can. So we're generally flirting with the lowest speeds we can out of our cylinder with the largest gap. And anybody that's had a Lexion combine for any period of time knows that can be a bit of a slippery slope with keeping the impeller area clean. So as far as aftermarket bits and pieces go, the Sunnybrook impeller has been very beneficial to the Lexion combine in the 4 and 5 and 700 series combines. If anybody is currently running those, they'll know what I'm talking about. If you're not running a Sunnybrook impeller, I would certainly recommend it. It is the only aftermarket piece in the Lexion combine that I recommend. After that, our regular OEM pieces work the best, in my opinion. And then as far as rotor speeds go, out the back, being the only one in the industry that can have our threshing area and separation area speeds different, I recommend doing as matching those speeds as close as we can. Maybe running the rotor speed 100 quicker seems to be beneficial. Rotor cover plates generally can be closed at that point, so we're keeping pods and chaff out of our shoe area, and then we're working only with beans. Less handling of them, less returns, which in turn should get us a better product in the tank. And then as far as the tank goes, I know that time is everything at this time of year, but idling down to unload beans, seed beans specifically, it helps. I know that everybody wants to get going based on volume. This may not be possible, but if there is an opportunity to idle down and unload, it definitely helps. And then off of that, with 8000 series, we can also have a half speed unload, which allows us to keep going and unload at the half speed. Different from the 5 and 700 series, of course, but nonetheless, it is available in the 7 and 8000 series. Variable speed feeder houses. I'll move back to the front of the combine. Guys with the variable speed feeder houses can also experiment with that, slowing things down there, or speeding things up based on what we're learning throughout the day. Can also be beneficial. I can certainly answer any questions based off of those comments so far.
Hi, Scott. Leo right here. Just wondering if you could touch on why a round bar APS grates would be better than the smooth.
The round bar, well, the smooth, we find that based on the size of the bean, and we're yet to see this year what we're going to be working with, but we have found that based on the size of the bean, some of those are struggling to get through the smooth. With the round bar, of course, we're working with a little bit larger gap and less square edges. And of course, we're getting it dealt with at the APS area, so punched down through the round bar APS grade and then onto the prep pans, and our threshing cylinders never see them then. So we're seeing improved bean quality at that point with some of that threshing getting done there.
So you'd leave your desoning plates open at that point with the round bar sieve?
Exactly. But I have seen even some isolated instances where we were struggling with pods, a high volume of pods. So we closed the desoning plates, and now we're rolling those beans over round bars, acting as a bit of a threshing area versus a smooth, which now we're just rolling or pushing them right towards the concave. Or in some cases, I've seen guys leave their raised bar in there, and now we have a real problem. So definitely the round bar is what we're recommending, or the larger hole smooth. We've also seen some success with that.
Hey Scott, Brian Weir here. Just wondering if you have ever seen anybody play around with gearing down the unload auger on like a 700 series for unloading on the go?
Good morning, Brian. Back in the early 500s, we did have some test kits that were available. In the 700 series, I have not seen that, but I can make a phone call to find out if there's anything available. And I can definitely reach out to you personally there and get you any information that I do have. I know one time they did have that available.
Okay, thanks.
Neil here from Ontario. Just a quick question. So in Ontario, the moisture can fluctuate quite a bit within the harvest day, starting, at 16 perhaps, and going down to 12 later in the day. Like, how often would you expect the operator to have to change and make changes to combine settings in order to maintain seed quality, keep pods out, not crack the seeds, that sort of thing?
Well, of course, with the higher moisture product, we're able to get away with maybe running things a little bit quicker, which can increase our capacity throughout the day. And then as the bean dries down or any of our product dries down, we're having to work with it a little bit more careful. So do I expect 20 changes throughout the day? No, I don't, but I do expect in the heat of the day for us to have to maybe slow things down a little bit when the bean is at its driest, and then we can get away with a little bit more cylinder speed, or maybe even perhaps a little tighter gap when the bean's at the higher moisture, and we can get away with it at that point. But I would say at least a couple changes throughout the day, minor changes some days, a little more extreme changes other days.
Okay, thank you.
Feel free to ask questions, guys. It's a pretty open forum here.
I get one question from myself here is just in a lot of the results that I've seen with our Lexion models that we work with, our splits seem to be a little bit more variable. How, from your perspective, do we manage that? Like, is there a trick to just getting that right down to next to nothing? What's your take?
Well, down to nothing is a bit of a slippery slope. We're always trying to achieve the minimum amount of damage to any crop that we harvest. But I do believe that there is some things that are being overlooked often. And the intensive thrashing segments that I talk about, I believe is one that is overlooked often. Even potentially blanking plates that are in the cylinder for harder threshing crops, we can take them in and out. So guys will overlook or just simply forget that they've taken or putting these in. So disowning plates are sometimes overlooked as well. It's a small lever on the side of the combine that that gets overlooked. So making sure that that's open, making sure that we have our intensive thrashing segments out, making sure that we have any blanks that are in there, that they're out. And as well as our combines age, we do find that we have some wear in the impeller area, which then creates backfeeding. And backfeeding can be an issue because now we're working with the crop the second time. and when we only need to be doing it once. So if we can eliminate some of the back feeding, and we could be doing that with Sunnybrook components, a lot of cases, or new impeller area components, wear kits, etc., which we're only dealing with the crop once, not twice. And more crop on crop, more we can get away with, where we're having the crop thrashing itself versus metal on crop is always a better scenario for anything that we're dealing with. Large gaps, low speeds. Concave level, I guess, if we're going to get right into the details of possible things. I have over the years seen many cases where the concave is out of level. Growers have maybe overlooked combine inspections perhaps, or what have you, but unlevel concaves can cause this as well, where we're seeing extremely tight on one side and large gaps on the other, which creates inconsistencies amongst the crop as well, the final product. Combine inspection should take care of that problem, but sometimes they're overlooked.
I got a question. I'm pretty new to combining, and I just want to know if there's like a website or a YouTube video that I can go check out to see how I can adjust all this stuff. Basically, go over everything you just said. That doesn't quite compute with me, but
yeah. So there's a couple different options that we have here. Claus has a CMOS app, and which is downloadable off the website or off the internet. And CMOS is the automated features that Claus has developed. If your combine is not capable of CMOS, you can simulate CMOS, where it's on your phone and you tell the app what it's doing. If you're seeing too many pods in the tank, or if you're seeing cracks, et cetera, they will give you suggestions, and then you answer yes or no. Has my cracks improved or not improved? Yes, no, and it just walks you through a series of things. So it's Claus CMOS is the app that I often recommend. As we're all aware, with the Claus combine or Lexion combine, we can load a crop setting, which then adjusts our gaps, sieve adjustments, fan speeds, et cetera, and then we can build off of that. So it's not like we're starting from ground zero. We can go in and load a soybean setting, and then we build off of that, whether we're increasing cylinder gaps or decreasing cylinder speeds, and we can save those in Lexion combine. If we find something that we like, we can save it under seed soybeans or whatever crop that we happen to be in, and we can revisit that when we the following year, so we don't have to keep remembering.
Hey, Scott, can you speak to how you would go about setting your grain loss monitors, and the most effective way to do that?
So as far as the grain loss monitors in our Lexion combine go, they are to be trusted. This piggybacks off of my comments on loading crops. So if you had a canola crop setting loaded, the sensitivity levels would be much higher, of course. If you have a heavier crop, a soybean, larger bean crop, they're going to be less sensitive just because of the pure volume and weight of the crop. So again, recommendations is that you load the crop setting of the crop that you're in. And a lot of cases, I like to lower the setting just a little bit, despite the fact that I truly believe that we have a grain loss monitoring system that should be trusted. I always like to make it sure that its accountability is just a wee bit more. So if it's set at 65, I'll often lower it to 60. Increase my sensitivity to make sure that when my loss monitors are acting up, that I trust and believe that they are throwing over, and we need to make an adjustment around that. Believe your monitors, guys.
Can we speak about just wind speeds a little bit, and how you feel like an effective way of setting those wind speeds?
Well, when it comes to wind, in election combine, my preference is always to get as much wind as we can on it. And as the day rolls on, that's going to change a little bit. But getting as much wind on our shoe before losses is definitely my recommendation. So if we're working with an 1100 or 1200 RPM setting, throughout the day, I'll find myself trying to get away with putting a little more wind on it until we see some losses, and then back off. Right, with soybeans, they're pretty forgiving. They're a bigger product. The pods are often dry, and they don't want to stick around much. But we will see some higher return levels if we're perhaps some lower sieve adjustments are maybe a little bit on the tight side. But nonetheless, if we can get wind on soybeans and we can get rid of the pods quickly, that's always the best. Is there anybody on the call using CMOS, a full-blown CMOS automated system from Claus? We'll leave there is some pretty interesting things when it does come to CMOS. If anybody has the opportunity to give it a whirl, I would recommend it. It's pretty cool, especially when it comes to the grain quality cameras. It's going to be adjusting itself based on what it sees. Pretty leading edge stuff, in my opinion.
Do you mention that that's available on all combines, or
No,
just the 8000 series?
Primarily 8000 series. We do see it in some 700 series as well. But it was pretty new at that point. So there was a relatively low take rate there. But the 8000 series, we've seen some pretty significant advancements in the CMOS side of the business, and some pretty cool results as well, especially with the seed quality cameras. The combine is reporting to itself and adjusting as required.
In a lot of situations with seed production, we're pushing the maturity level to the early side and seeing, greater pod situations come into the combine. And a lot of times that ends up forcing our pods through the return, and we're putting a high load on the return. To the point of plugging almost sometimes,
Mm-hmm.
And I know you don't want to be too aggressive on the front end of the combine because you're risking seed crack and germ quality issues. I don't know if there's much we can touch on that I don't really know about, but if you have any insight into how to deal with that green pod issue going through the combine.
Yeah, dealing with it early always, Lee, is best, right? With Lexion combine, if we can get it done with the disawning plates open at the front and a round bar grate or a larger hole grate there, just to get it dealt with there, and then of course the wind. But yes, it is. Green pods can be a bit of a challenge, challenging our return systems for sure.
One thing I could offer there too, Lee, is I definitely have noticed more growers doing desiccation the last couple of years than previous, and it has made a huge difference for dealing with excess pods and stuff in your samples. So I would encourage everyone on the call, if you haven't tried it, you should. You can use, well, I'm speaking here specifically for Manitoba, sorry, you Ontario folks and Washington people, you have different product names, but Reglone and Heat are options for your seed production, and they work great. We've noticed substantially once those samples have been hauled into our conditioning facility that those loads that have been desiccated, you can tell made a huge improvement on quality. Helps thrashing things a little bit easier too. So I would say it is definitely worth a try. Maybe not on all of your acres, but if you want to try even a quarter or a half section to get you started with harvest, it's really nice. That is kind of a question I had for you too, Scott, is like with the production that I've been looking at here in Manitoba anyways, we have a lot of like huge plant mass and quite a few lodged plants. Do you have any suggestions for, like, dirt tag is definitely one aspect that we try and limit as much as we can in production. I know having some lodged plants, we might have that more of an issue here this year. Do you have any suggestions for us on how to pick those up or anything like that?
Yeah, the lodge crop this year, I think, is going to be something we haven't dealt with in a long time. So we're all going to have to re-educate ourselves. But header quality, cutting component quality, the introduction of air bars in some cases can really help with that, as crazy as it sounds, but keeping our cutter bars clean with air bars, good cutting components to keep things moving along. Generally, the header is our limiting factor when trying to keep the combine full in soybeans and in other crops. So if we have our header in good shape and we're able to clip along at a better pace than we are with boring components, that always helps pushing the crop along. Air bars, like I touched on, huge for two reasons. One, it puts more in the tank, and two, it keeps things from hanging around on the header. Pushes them to the back of the draper and into the combine they go. Longer any sort of plant hangs around on the header, there's a pretty good chance we're going to lose it at that point. So good proper setup on MacDon headers is critical for wing sensitivity, float sensitivities. And then when we go to the auger headers, of course, making sure that we've learned our upper and lower limits and that our header is as light as possible without leaving anything behind. Is probably the moral of the story there. We can make the headers light, but then we're leaving something behind. So will mud come into play this year? I hope not. Mud and lodged crops are generally not a great mix. So let's keep that in mind, guys, when we're setting up our headers, that we're making sure that our sensor bands are all free and loose and free of material, that our skid plates are all intact, and that we have no holes in them to have mud catching up in them. Making sure that our crop dividers are set properly as far as float goes. We need to make sure that those are doing their job out on the edge, so we're not tugging and pulling at plants, because that even makes a worse mess, because now we got a plant that's been pulled out of the ground and now we've got it sitting on the draper as well. So you touched on dirt tag a little bit. Well, let's leave the dirt in the field and the combine can take care of the crop. But yeah, headers could be very important this fall, as they are in the past, but this year could be even more important.
Do you have much experience putting lifters onto headers, or recommendations for them?
I do have quite a bit of experience with lifters. In my opinion, they're a bit of a scary animal. I prefer them riding on the back of the header versus on the front of it, but I understand that we have to get the crop off the ground. Making sure that they're in good shape is key. I've seen lots of header situations where we've got missing crop dividers or bent crop dividers, and they're not doing the job that they're supposed to. So with the increased technology in flex headers, I've seen less and less of the crop lifters used, but I sense that this year we could be back into the lifter category. The half moon ones are my least favorite, despite the fact that they sometimes work the best. They're extremely hard on combines and tires if they don't remain where they're supposed to. The flex type or the B type ones seem to work the best, and they seem to create the least amount of headache when they're not doing their job.
we're coming close to your time here, but I would like to just end it with a question for you. From your experience, like a lot of, like we're combining soybeans, which everyone's familiar with, but this is seed production, so we're treating it a little bit differently. And I think a lot of the things that we practice with edible beans kind of runs true with how we treat seed production soybeans specifically. From your experience, Scott, like, is there anything that edible bean growers are doing differently than that we should like maybe be taking a tip from and moving into our soybean seed production?
I would say probably the biggest takeaway from that is our impeller area. It's hugely important and often overlooked because everybody thinks that we're done with the crop at that point, and now we just need to get it to the rotors and we should be good. And we find a lot of bottlenecking there, and we find a lot of problems areas there where we're backfeeding and dealing with that crop twice or in 3 times in some cases, based on how worn that area is. So the bicycle seat area or the horn area between the 2 rotors, we often find based on the year of the combine or the age of the combine or the hours in the combine that area is worn. The center portion of the impeller is worn, and it creates nothing but headache. It prevents us from running at the lower speeds that we want to achieve the best seed quality. So the guys just keep bumping up their cylinder speeds, which in turn bumps up their impeller speeds, and it kind of masks the problem. And the end result is poor seed quality. So if I had any recommendations for anybody on this call, is that hop in their grain tank, pull off their grain covers or the impeller covers and have a peek. If it's worn, it needs a wear kit. If it's full of dents, holes, whatever the case may be, it needs to be replaced. I recommend a Sunnybrook impeller. We have found it's been hugely successful. Anybody that's running it will know what I'm talking about. We can get lower speeds, and lower speeds with larger gaps create better seed, better crop in all general. So Sunnybrook cylinders as well. We've seen, I know there's at least one grower on the call here that has both, and Sunnybrook cylinder and impeller, and I don't know if that farm would farm without those products. It's beneficial in all categories. So but that's generally the case, and the guys overlook their intensive thrashing segments. The guys forget that they're in there, and that is just simply another pinch point in an area that they got to drag crop across that they don't need to. Half a dozen bolts and they're out, and then they can be put on the shelf for another day. But those are my two stickler points to deal with.
Hey Scott,
those are really good tips.
Sorry, Stacy. Scott, does the 8,000 and 7,000 series use the same APS grades as the prior series?
Yes, they do. Yep. Yeah, wide and narrow body inclusive. So if you had a 740 and you were going to a 7,500, the APS grades are the same. I know there's half a dozen or maybe even 8 now, different options for that as well. They keep growing every year.
Okay. And wide body are wider, or is there
Nope.
4 of them?
Nope, 3. They're just wider. Same number,
Okay.
just wider. Yeah.
Okay.
So if you had a 760 and you move to an 8600 or 8700 or 8800, those APS grades are repurposed into the next series.
Okay.
Awesome. Good discussion, everybody. Thanks for asking some questions. Really good opportunity to pick Scott's brain here. And you had so many good tips, Scott. I really appreciate you sharing that with us. We just want to try and improve our quality the best we can. And those are some really good ways to implement it for this upcoming harvest season. So we will probably be calling you, I'm sure, in the next couple months. So thank you very much for being on the call this morning. And if it's okay, I'll share your contact information with all the folks on the call, and we'll reach out to you probably again.
All right. Thank you very much, Stacey.
Awesome. Yes,
Safe harvest, guys.
Yeah, thank you.
Thanks,
So
Scott.
with that, guys, I think we're going to transition over to James. Now, those of you who were on our spring call this year may have heard James present. He's from Ontario, and gave such a really good presentation on storage, and I've kind of coined him just being the most knowledgeable storage expert you'll just ever meet. And James has heard me say that about 4 times over the last couple weeks. So if that hasn't inflated your ego, I don't know what will. So James is the engineering specialist for OMAFRA out of Ontario. He's based in Vineland, Ontario, and he was raised on a cash crop and hog farm in the Niagara region. He completed his mechanical engineering degree at the University of Waterloo, and he works for OMAFRA, focusing on best practices, innovations, environmental impacts of grain drying and storage, precision agriculture, field equipment, and on-farm energy use. So with that, I'll hand it over to James, and he's going to run through a really nice presentation preparing us for the upcoming harvest season.
Thanks, Stacy. Yeah, I mean, I appreciate those comments. As I've said before, maybe you need to meet some more grain storage experts, but in all honesty, you know, I don't pretend to have all the answers. I know that many of you on this call have a lot more experience storing grain over many years and drying it than I do, but I hope to give you some things to think about, maybe a bit more from the research side or some of the science behind it that can maybe help you think about your grain storage in a different way and do things, you know, maybe see some opportunities where there could be some improvement. And yeah, for those of you that don't know me, my name is James Dyck. I work with the Ontario Ministry of Agriculture, Food and Rural Affairs. And one of the things I do deal with is grain storage and how to do that well. So I'm going to talk just over a few things. First, we'll start with maybe some of the scientific background and air conditions, relative humidity, and why that's so important when we talk about grain drying. We'll talk about airflow in particular, because that's really the tool that we have once grain is out of the combine. And in a bin, airflow is kind of the only thing we have to manage that grain. And then finally, walk through kind of the drying and storage system and hopefully give you some things to think about as you're planning for this season. As we know, the crop in some cases went in a little later than we wanted it, and so potentially we may be into a later harvest, potentially a little wetter, and I know that always brings concerns. My phone usually rings at the end of October, November, December, people saying, hey, you know, I have beans still out in the field, what do I do with them? They're still wetter than I want. And the answer is combine them and dry them, because you can do that with soybeans, even if they're a little wet. But what you're seeing in this chart here is that when you do have wet beans, you do want to get them dry. The moisture of those beans is really going to impact how long you can safely store beans before they start to spoil. And as you can see, certainly hot and wet is not a good combination. It'll start to spoil almost immediately. Even cold and wet isn't great. You might get a couple of weeks of storage out of it. Hot and dry is okay. It'll store for a little while, but really cool and dry is where you want to be. Fortunately, in Canada, we have the advantage of nice cold winter weather that allows us to cool our beans down quite nicely, but we also want to make sure they're dry. Now, when we look at seed in particular, and questioning, you know, what does temperature have impact on germination? There's some data that I found out of an older USDA handbook. I really like this data because it's got a really wide temperature spread, including storage down at -10, and it's comparing its germination. So what you can see from these charts is at various temperatures, basically the germination will decrease over time, as we all know that it does. And the wetter the beans are, the faster that's going to happen. But at very cold temperatures, so frozen beans in the middle of winter, let's say, even very wet beans, the germ will hold for a long time. And that's good news, because for those of us that maybe do harvest some seed beans a little wetter than we wanted, and maybe don't have an opportunity to fully dry it before winter hits, freezing it down over winter and then either restarting the drying in spring or you know, taking advantage of drying when we can, that's a very workable strategy, and you're not going to impact your germination significantly. Of course, as it gets wetter or warmer, pardon me, and with wetter grain, that becomes a bigger problem. Now, something to watch for, and something that's really important when we talk about drying and storage, is relative humidity of the air around you. something we hear all the time on the weather forecast. The first thing you say, it's, so many degrees out and so many % relative humidity. But what does that actually mean? So if you think back to maybe high school or college science class, maybe that was a little further back for some of you than others. But if you picture the air around you, air can hold and absorb water. We know that. That's what relative humidity means. It's a measure of how much water the air is holding. And so at a certain temperature, let's say 0 degrees, our air can hold a certain amount of water. We can picture that like a cup, like an empty cup. And so if we have humidity, that fills up our cup. If we have 100% humidity, our cup's right full. That means that water can't hold any, or that air can't hold any more water. In fact, if we tried to dry grain with that air, it would probably dump that water back into our grain and make our grain wetter. So that's not good. But we can actually control relative humidity by adding some heat. And if we heat up that air that was at 0 degrees, we're actually increasing our capacity of that air to hold water. So by heating up air by 10 degrees, you effectively double its capacity to hold water. If you haven't added any water while you're heating it, then we've essentially cut our relative humidity in half. And we can do that again. So you can see that by heating up air, we very quickly turned air that was not suitable at all for drying to air that will very readily absorb a lot more moisture from the environment around it. And this is how a grain dryer works. In fact, for a high temperature dryer, it's going to heat the air up so hot that your relative humidity essentially becomes 0. And that's just going to suck the moisture right out of that grain. But what you might not know is that grain will eventually equalize to the environment around it to a certain moisture level, depending on the temperature and humidity. And that's what this chart tells us. It's called an equilibrium moisture chart. So as an example, the room that I'm sitting in right now is probably about 20, maybe 25 degrees. It's a little warm here in Ontario today. We might get some rain later today. Actually, it's rained a bit already. But say 25 degrees and say it's 50% relative humidity. Well, if you look that up on the chart, that means that if I had a pile of soybeans in front of me, it doesn't matter where that soybeans start, if it's 20% or if it's 2% moisture, eventually those soybeans are going to equalize in moisture with the air around them, which is going to be at about 8.3% moisture. Call it 8.5. Of course, that's a little on the dry side, so we probably would want to have air that's a little more humid, ideally. But what you'll find is that for soybeans, and in fact for most grains, the humidity that we want to achieve is roughly 60 to 70%. That's going to get us in the range of where we want that grain to be stored long term without significant over drying. The good news is that we, even in Ontario here, where our climate is probably a little wetter than what you might experience in some parts of Manitoba, we achieve 60 to 70% humidity quite often. Like that's pretty close to our average humidity. So obviously it gets wetter some days, it's drier other days, but over time that does tend to be close to our average. So we can use this equilibrium moisture principle to dry our grain by running our fan. We're eventually going to get our grain to around that moisture if the average humidity is somewhere around 70%. Now, obviously that fluctuates a lot during the day, so it's important to have a reliable source of weather information locally, whether it's a weather station on your own farm or one close by that you have access to, where you can kind of track what is the relative humidity doing over time and what does that mean for my grain. Because obviously, if it's very humid out, you probably don't want to be running your fan to try and dry your grain. You'll end up with grain that's a little bit wetter. Thankfully, there's actually a tool online that can help us. It's called Bincast. Perhaps some of you have seen this. It was developed in Ontario. It does work in Manitoba. I can't comment on the reliability of the weather data. I don't know what Weather Innovations Network is like in Manitoba, but essentially this tool pulls local weather data and it will give you a prediction of what's your temperature and relative humidity going to be over the coming week. And then it will also tell you every hour what's the estimated equilibrium moisture going to be. So I know the text's a little small, but in this example, you can see that, at the start of this day, or at 1 p.m. rather, you could aerate your beans and you'd be around 11% moisture, which is fantastic. But then by 6 p.m., it had crept up quite quickly. So not sure if there was a rain event or something that was happening, or predicted to happen, but you can see how quickly things can change over the course of a day. Bincast is great because you can see the whole week ahead of you, and so you can use this to plan out. If you know you're going to need to aerate or dry your beans, you can take a look at what's the forecast and say, well, okay, it looks like this day is going to be a good day for aerating and maybe this one's not. So you can use that to plan out when you might need to run your fan. Because airflow is the only tool that we have to manage grain once it's in a bin. If the grain is very wet, we do need to actively remove moisture from it. So you're going to need a larger fan, something at least 1 to 2 cubic feet per minute or CFM of airflow for every bushel of grain you've got in that bin. You're not going to want to put more than about 10 to 12 feet of grain in the bin. If you put more than that, first of all, it's going to take longer to dry. And secondly, your fan's going to have to work harder. You might actually get less airflow. I'll show you more about that in a minute. It will take some time to dry. So this isn't a fast process. This isn't like a high temperature dryer. We're trying to do this with natural air or maybe a little bit of extra heat. So it will take days or even weeks to fully dry, and it will dry from the bottom up. So this is another reason why we want to be watching that humidity. We don't want air that's too dry going through. We'll end up over drying the bottom of that bin while the top of the bin is still very wet. Now, once you can keep an eye on the drying by taking samples of the grain at the top of your bin, because that's going to dry last. So once you see the grain at the top start to cool down and particularly see the moisture start to drop, then you'll know that the drying is almost complete. Another way to monitor is you can put tubes in the side of your bin, especially if it's a bin that you're planning to use on a regular basis for drying. You can put sample ports maybe every couple of feet up the side of the bin, small pipes sticking in a little ways. That just allows you to grab a small sample of grain and take a moisture sample, so you can kind of monitor the progress of that drying front. If you're aerating your grain once the grain is dry, really then what we're trying to accomplish is just to keep that grain cool, keep the temperature consistent throughout, keep the moisture equalized. So you can get away with a lot less airflow for that. Grain depth isn't as important, and it'll be a lot faster when you're just changing the temperature. It's just going to take you a few hours, maybe a couple of days. But it is really important to use the fan that you have on your bin, because that's the only way you can keep your grain in condition. Now, I talked a little bit about drying time. If you are trying to actively dry your beans using ambient air or low heat, it will take time. Obviously, it's faster in warmer weather and takes longer in cold weather. You can add some heat to speed it up. Another way to speed things up is to add more airflow, either by, using a bigger fan if you have one, or putting less grain in your bin. You'll increase the effective airflow per bushel. And those are two ways to speed it up. But as I said, it's not fast. It will take you a couple of weeks or even longer than that. So it's worthwhile to plan for this. If you know you're taking beans off that are going to be a little wetter, make sure you're prepared to dry them down with the time that it's going to take. If you are just trying to aerate, meaning you're trying to cool it down, the grain's dry or mostly dry, that's going to take a lot less time and you need a lot less airflow. You do want to aerate your beans after filling the bin, even if they're dry, because you do want to pull out that field heat. As you saw on the first slide, hot grain will spoil much faster, and the germ will not be very happy. So you do want to cool that grain down. And you also want to be running another aeration cycle every time the average temperature outside drops another 5 to 10 degrees. So probably 3 to 4 aeration cycles, between harvest and winter time to continually cool that grain down. If you don't, you can run into some issues in the bin that we'll talk about in a bit. If your grain's very dry in a bin, you can get away with a lot less airflow. If your grain's a little on the tough side, you probably want a little more. You don't need as much for drying as you do for drying, but you still want a little bit higher airflow. So it's worthwhile to have reasonable sized fans on your bins. Having said that, though, it's important to note that your fan doesn't always perform like you think it does. You should call your fan manufacturer. First of all, make sure you know what kind of fan you have, and then ask them for the fan performance chart. Because what you'll find is that different types of fans with the same size motor perform very differently. That's what I'm trying to show in the chart on the left. You can see that an axial fan has the highest airflow, but it performs very poorly at high pressure. In fact, it drops off the quickest. Whereas a centrifugal fan, especially a high-speed one, has much lower airflow, but it can push a lot more pressure. And pressure, static pressure, is basically how hard your fan has to work when it's pushing air through the grain ahead of it. So obviously, the depth of that grain is going to increase the static pressure, and the more air you try and push through that grain is also going to increase the static pressure. So you can use a chart like the one on the right to try and estimate your static pressure in a bin, but you can also measure it. You can get a gauge. You can just stick that gauge on the side of your bin and literally measure the static pressure in your plenum when the fan's running. Now you do need a gauge measured in inches of water because a PSI gauge, 1 PSI is about 28 inches of water. So it's not even going to register on that kind of a gauge. So we are talking about very low pressures here. It doesn't take a lot of pressure for a fan to start losing airflow. You can also do it even more simply than that. You can get a clear piece of hose, maybe something laying around from your sprayer, fill it with water, put one end of that hose into your plenum and turn on the fan. And what you'll see is the water, there's going to be a height difference in that tube. That height difference measures your static pressure. So if you take that measurement, that's literally your pressure in inches of water. And you can take that number, look back at your fan chart, and then get an idea of how much airflow you're actually getting into that bin. You can also estimate it with another online tool. I really like online tools, so I like to share them with others. This one comes out of University of Minnesota. And what you can do here is put in your dimensions of your bin, how deep your grain is, and they've got a whole database of fans. So you can probably find the fan that's on your bin in their database. You can pick that one, and it'll tell you, based on what you've entered, how much airflow you're getting out of that fan at various depths of grain. You can also use this tool if you're designing a bin, not sure how big a fan you need. If you want it to be a drying bin, you can tell it you want at least, say, 2 CFM per bushel of grain, and it'll tell you roughly the size of fan you need for that. So it's a really useful tool. It can give you an idea of what's going on with the airflow in your bin. A couple of other things to keep in mind as you're planning for drying. It's important to get the fines out. So if you have a flat bottom bin, a good way to do this is by coring the bin after you fill it. That basically means taking out a load or two. You'll get the funnel flow and get the center core of that bin out. That's where the fines and weed seeds and stuff tend to collect as you're filling the bin. So that can be a good strategy. Unfortunately, it doesn't work very well in hopper bins just due to the shape of the bin. You get mass flow of grain, so all the grain kind of comes out at once. So if you've got a situation with lots of seeds or fines in it, you're going to want to try and clean those out before you put the grain in the bin, either using some kind of cleaner or maybe making some adjustments to your combine like Scott just went through with us to try and get that sample a little cleaner. If you don't do that, then you're going to have more static pressure because those weed seeds and fines are taking up airspace in your bin. And especially if they're gathered in the center of the bin, you'll end up with a lot less airflow through that central core. You'll have grain staying wetter a lot longer, and you could have some problems there with spoilage. Same thing when it comes to leveling a bin. It is really important to try and get that grain level because that's going to get the airflow to be most consistent through that grain. If you've got a nice big peak in the center, obviously, you filled your bin right up, but you've got much deeper grain here than you do over here on the side. If you remember your static pressure chart, the deeper grain has a lot higher static pressure. So you'll get the air preferentially going around the outside of that bin. It's going to be a lot less air through the central core, again, just due to the grain depth, and you'll have a much more likely to get a wet spot or spoilage in there. Now I've talked also about adding heat. It's pretty easy to do this. You can get a portable heater like the one pictured. You can get heaters that'll bolt onto your fans like this, whether it's propane fired, natural gas if you have it. You can also use electricity if that's available to you at a reasonable cost. And the success here is going to depend on your heater size, the fan airflow that you have, and you do want to pay close attention to your equilibrium moisture chart, because what we're really trying to do here is not heat up the air so much as dry it out and remove that excess humidity to bring that air into that 60 to 70% relative humidity zone. So again, having a weather station close by is really important because that can tell you whether or not you need to be running your heater to dry out that air a little bit. How much heat you need to add is probably in the range of 10 to 20,000 BTUs per 1,000 CFM of airflow. That's going to allow you to drop your relative humidity somewhere between 10 and 40%. So you don't want to be dropping it any more than that, because then you're getting into over drying territory. But somewhere in that range, maybe even a little less than that if your day's not very humid. So if you can find a heater that has adjustment on it, that you can tweak the amount of heat coming out. So if it's, you know, a drier day, you only want a little bit of heat, you can turn it on a little bit. And for a very humid day, you crank it right up. But that's the range of heat that you're probably looking for. I certainly wouldn't go outside that range of heat. Once your grain is dry, you do want to keep running your fans occasionally to keep that temperature close to the outdoor temperature. And the reason for that is if you don't do that, what happens as the air cools down around that bin, but you've still got warm grain in that bin, you get condensation of the grain close to the wall of that bin, because that's going to cool down just from conduction from outside. And so then you'll get air moving to the warmer zones, because we all know hot air expands and rises and moves. So then the cold air takes its place. You'll end up with moisture migrating to the top of your bin. And you'll see this because you'll see condensation inside your bin roof. So if you've ever seen that, that means you've had moisture moving inside your bin. That condensation hasn't come from outside, that's come from inside the bin. You'll get a moisture zone at the top of your bin, and that's where you'll start to see the spoilage. You can prevent this by running that aeration fan and trying to keep the grain reasonably close to the outdoor temperature, because then you just reduce that differential. Now, the opposite thing will happen in springtime, especially if you store grain into summer and it gets very hot. You'll get warmer grain to the outside of your bin, colder in the middle, and you have the risk of moisture gathering at the bottom of your bin. And this you're not going to find until you go to empty that bin. So it can be a good strategy if you're storing your grain well into the summer. You probably want to think about warming that up after winter. Still keep it on the cool side if you can, 5, maximum 10 degrees centigrade. So that probably means aerating it at night, but maybe don't try and keep it frozen. Having said that, I know some of you maybe are moving your grain in winter, you're moving it in December or January. You don't really need to worry about warming it up too much at that point. I'd suggest running an aeration fan before you ship it, just to make sure that everything's equalized and in good condition. But if it's being shipped in December or January, it's probably going into another bin, and they're going to keep it frozen anyway. So not a huge issue there, trying to keep that cool in wintertime. The last thing you want to be doing is checking your bins frequently. You've got a lot of value in there, and you want to preserve that. So check your bins regularly, every couple of weeks, maybe a little less in winter once it's frozen down, and maybe a little more often when the weather's warm. Use your eyes, see if there's any signs of spoilage. Check your static pressure if you've got a gauge on that bin. You shouldn't see the pressure increasing. So if you do see a static pressure increase over time, it means something else is in there, maybe molds or insects or something, and you really want to check that out. If you smell anything bad, you want to get those beans out quickly. That's not a pleasant smell. And you certainly want to keep written records of any inspections you've made, so that you can see whether things have changed over time. Of course, there's lots of tools out there you can use to help you do this. Many of us are familiar with temperature and moisture cables you can get for your bins to see roughly what the inside conditions of that bin are like. There's a newer system that you're seeing in that graphic on the screen. I think this actually came out of Manitoba. It's called GrainViz. And what this system does is you put sensors around the inside of your bin, and it will scan your entire bin and tell you how wet everything is throughout your bin. So that was kind of the graphic showing you the different moisture levels. It's quite expensive, but it is really interesting to see exactly where the wet spots are in your bin. So if that's something that is concerning to you, could be worth looking into that. Another more cost-effective option that's come out recently. Yeah.
Sorry, is that monitoring system transferable, or is that bin by bin installation?
That's a good question. It is bin by bin installation because it relies on sensors kind of throughout the bin. So whether you can, I don't know how much work it is to move bin to bin, but it's kind of one of those things that you would install and leave it there. So it's not something you could sort of move from bin to bin and check each one individually over, one season. You'd need it in the bin before you filled it, is my understanding. And yeah, please jump in with questions if you have them. I'm almost done, so we'll have time for a couple questions, I think. Wanted to say one last item you can get that's more cost effective is a CO2 sensor. This hangs in the roof space of your bin, and the advantage of this is that CO2 will diffuse through your bin a lot faster than temperature or moisture will. So you can detect spoilage sooner, because spoiling grain will generate more CO2. So another benefit of these types of systems, even temperature moisture cables, you can integrate them with your fans. So you can tell it, I want to maintain my grain at a certain moisture level, and it will run your fans based on the outside humidity to try and do that for you. So that's a good way to help you manage some of your grain. Finally, if you do ever have to go into a bin, please be safe about it. Never go in when the auger is running. Always have somebody on the outside who can help you, who can call for help if needed, and always wear safety equipment like a proper harness and a proper safety line, not just a rope tied around your waist. I know that can be a pain to work around, but it's much less of a pain than getting buried in grain. There are deaths every year from grain entrapment that are completely preventable. I know sometimes grain does get stuck in a bin, but please be very careful when you go into that bin. Grain is like quicksand. You will not be able to dig yourself out. If you get trapped, they have to use special rescue equipment to get you out. So please be cautious. Your life isn't worth doing that. You're worth more, and you're worth a little bit of safety precaution. So just wanted to say that. In summary, you definitely can dry wet beans. You can harvest them and dry them. It will take some time, but it's certainly doable. Again, if you don't get your beans quite dry before winter, you can freeze them down. They will hold, and it won't impact your germ. So you can continue the drying in springtime. You can add low heat up to 20,000 BTUs, but certainly if you have a heater with some adjustment on it, I definitely recommend that. Keep your drying temperatures low and keep your relative humidity high, both because you don't want to over dry the grain, and also if your relative humidity is too low, you can actually get cracking and splits in the beans. And then finally, once they are dry, aerate them to keep them cool and dry in storage over time, and monitor your bins frequently. So that's what I had. I hope that I've given you some things to think about. Happy to take some questions. My contact information is here. If the questions don't occur to you today, they occur to you down the road, please feel free to get in touch. I'll make sure Stacy gets a copy of these slides. I know I put a lot of information in here, so I'll get them to her and she can send them out to all of you so that you have this as a resource. Happy to take any questions, and thanks for having me. So maybe
thanks, James.
I made everything clear and nobody has any questions.
Well, I was going to say, I've listened to your presentation 3 times now, and I'm just starting to like have a little bit trickle into my head. And I'm like, if I can absorb a quarter of your knowledge, I'll be really happy. You've got such good information. One thing I was going to say is I really like the idea of adding those sample ports that you mentioned on flat bottom bins. Can you do that to hoppers, or is that not an option?
I think you can do it to any bins. I don't know if it's an option from a supplier. You might have to ask different suppliers if they have that option. But as far as a retrofit in your own bin, it wouldn't be too difficult to, drill a 2-inch hole and shove a length of pipe in there, maybe weld it in or seal that hole up, just so you can have a sample port there on the side of your bin. I mean, be conscious of your own bins. Depending on the type of bin, you might want to ask your supplier just to make sure that it's not going to compromise the structure of the bin. But I mean, most steel bins can deal with a few small holes in it like that, and especially because you're not leaving it a hole, you're putting a pipe in there. So I think it's a good option to let you be able to get your hand in there and pull out some samples at various depths. Otherwise, it's pretty hard to do that. You might have a sample port down low sometimes on the unload auger. Otherwise, you got to reach in through the top. So you don't really know what's going on in the middle there. But having those sample ports kind of distributed along the height of your bin is one way you can get samples out at different levels in that bin.
For roof condensation on a hopper bin, so roof fans,
Yeah.
We've got a few we use, we exhaust, and I know other guys that swear you should be pumping air in. So we're sucking it out. They believe you should be pumping it in. And there seems to be a little bit of a debate on that. I just wondered if you had any input on that.
Sure. So what you're saying, Brian, is you've actually got the fan on the roof and you're sucking air in from the bottom up. You don't have a fan down at the bottom.
No, there's an aeration fan in the bottom.
Okay.
And then to exhaust the warm air,
So
so there's no roof condensation.
You got a second fan on the top. Yeah, that's definitely a strategy that some use. It can actually it can help your other fan perform a bit better. It can help your aeration fan better because you have less restriction in your attic space now. You're actually forcing that air out of the bin rather than causing your aeration fan to try and force the air through the grain as well as through your bin vent. So yeah, that will help keep your attic space dry. And especially in a bigger bin, that can help get your airflow a bit more consistent. Because what can happen too, if you don't have good vents on the top of your bin, it can actually, even if your grain is level, you can still get air. You'll get different pressures actually in your attic space. So if the air is further from a vent, it's going to be harder for that air to get out. So by putting a roof exhauster on it, yeah, you'll keep that attic space drier, which is good. If moisture does get in there, you'll get that moisture out of the bin rather than allowing it to drip back into your grain. And you'll also help your aeration fan to be a little more efficient.
Thanks.
Quick question for you too, James. One thing you kind of touched on, but we try and encourage folks to run the fans to just remove that harvest heat right after harvest. On years where we've had extremely dry beans in the bin, like I'm talking like under 11% moisture, do you think that there's an opportunity for us to over dry beans just using aeration fans when temperatures are 25 above? Can you talk about that at all?
Yeah, so the risk of significant over drying is pretty low. The reason is you're going to change the temperature of that grain a lot faster than you'll move a lot of moisture around. It takes a lot more work to get that moisture out. So, I mean, I'm just going to jump back quickly to a couple of slides here. So first of all, just one second. Okay, I'm not seeing it. There we go. This slide, aeration timing. So you can see here, depending on the size of fan you have, in terms of CFM per bushel, it'll take you anywhere from a day to a few days to cool that grain down. So that's, say you're removing your field heat, might take you a couple of days to do that. If we bump back to the aeration time or the drying time chart, you can see we're looking like more like a couple of weeks, even in the very warm, dry weather of summertime. So it's going to take you a lot longer to pull out a lot of moisture. Yes, technically you will be pulling out a little bit of moisture when you're aerating the beans, but over a couple of days, maybe the very bottom inch or two might get a little drier than you'd want it. I think that's a risk you have to take because you do want to cool those beans down. So having that small amount of beans at the bottom that's a little bit drier on the drier side, that's going to equalize out over time. I'm not too worried about that. It's more about running that. If you run that fan for days and days and days and weeks, you could eventually over dry your beans. The flip side of that is if your beans are very dry going into the bin and you're running your fan on a more humid day, you can actually add some moisture back into the bin. I would be very cautious about doing that on a large scale because the beans will swell. And that can cause their own issues in a bin. They don't have a lot of room for expansion in there. So don't try and do that on a large scale without some serious consideration. It is possible. I've seen guys do it, but it takes a lot of very careful management to do that. But your risk of over drying when you're trying to pull out that field heat, because you're only running that fan for a couple of days to do that, the risk is pretty low.
Got a couple more seconds here. Anybody else got any questions for James while we've got him on the line? No problem. Okay. Well, thank you all for joining. This was super informative, and I feel like it's very timely just getting prepared for harvest here. That's going to start probably in a couple of weeks. I noticed beans in Manitoba have really started to turn here as of this past weekend. So I'm still estimating we'll probably only be getting in the field about the 3rd week of September, but it will be here before we know it. And I know we're getting into other cereals and oilseeds right now in Manitoba anyhow, so it is perfect timing to go over this. So thank you, James, for joining our call, and thank you to all of you guys that took the time to call in here this morning. If you do have questions, I'll be sure to make sure James' contact information available to you and these presentations from both Scott and James at a later date. So with that, we'll close this meeting, but thank you all for calling in, and have a safe and successful harvest. Bye, guys.
Thanks.
Thank you.